Alright, for semester 1 exam review, we please need to fix the date, obviously. I edited an old document, I did not change the title. My bad. So, let's do this. Which one of these matches what in the term bank? So this, from the vertex straight down to make a right angle, is an altitude. Okay. From the vertex and makes a right angle. Alright, this one connects two midpoints. Let's call it a mid-segment. The mid-segment connects two midpoints. Next one, it's from a midpoint, it makes a right angle. That's called a perpendicular bisector. It's from a midpoint and makes a right angle. So notice the difference between altitude, which is from a vertex, and perpendicular bisector, which is from a midpoint. Alright, so this one cuts the angle in half. That's called an angle bisector. Last one starts at a vertex, ends at a midpoint. It's called a median. Connects a vertex and a midpoint. Okay, so these are all the different lengths, segments we learned about in triangles. Number 2. We have these two statements, and it says, which of the following is statement B, given the condition of statement A? So if you read the Hunger Games, then you've heard the character of Katniss. The second one says, if you have not read the Hunger Games. Same order with not. Okay? So the same order with not, if you remember, is inverse. So real quick recap. Converse switches the order only. Inverse keeps the same order with nots or opposites. Contrapositive switches and makes it opposite. And then biconditional has if and only if in between. Number 3, given the conditional statement, construct the following biconditional. So remember, we're going to drop the if and the then, which is not there. And we're just going to write, you attend Lee High School if and only if. That's what makes it biconditional, is the if and only if your school mascot is a volunteer. Alright. Or in this case, a service dog. Contrapositive. So we're going to take you attend Lee High School and your school mascot is a volunteer. We're going to switch the order and make it opposite. So if your mascot, now we're talking about the mascot first, but opposite, is not a volunteer, then you don't attend Lee High School. Oops. So Does everyone see how that works? You have the order has been switched, and both have been made opposite. That's what a contrapositive is. All right, flipping it over. AB equals 13. If AB is 13, AD and DB are halves. Might as well label that now. AD, half of 13. I can press 13, divided by 2, control enter. 6.5 for each of these. All right, BC is 11. So that means BE and EC are the same. Again, 11 divided by 2. Control enter. 5.5 for each of these. AC is 14. Now remember, this is a DE. Okay, DE is going to equal half of AC. Why? Because DE is a mid-segment, and we know mid-segments are half of their parallel side. So what's half of AC? What's half of 14? 7. So 14 divided by 2 equals 7. That's how I get DE. So I just labeled everything on that triangle, so this will be easy to answer. What's DE? 7. What's BE? 5.5. What's AD? 6.5. Alright. Mid-segments. Use the following below to find the following measurement. Hey, across from 26 to 74. Across from 26 has to be 74. Okay, so now I'm looking for X, Y, Z, which I just labeled, so that's 74 degrees. And then I got to figure out this missing angle. We'll call it angle A. Okay, because I don't want to get confused with this other X. So let's add these up to 180. 74 plus A equals 180. Combine like terms, I get 148 plus A equals 180. And then I get rid of my loner. A equals 32 degrees. So that's going to be 32 degrees. Boom. That's the properties of isosceles triangles. Okay. 6. Solve for X and Y. Solve for X and find the length of AB. Okay. Please remember, for mid-segments, you're going to take the mid-segment times, so 2 times AB is going to equal WZ. Okay, 2 times this mid-segment, which is half, will equal the whole, 34. So 2 times 3x minus 1 equals 34. Let's distribute. 2 times 3x is 6x. 2 times negative 1 is negative 2. Equals 34. Add 2. Add 2. 6x equals 36. Divide by 6. X equals 6. That's one thing I was looking for. But I need to find AB. Now hopefully you know AB is just half of 34. Okay? So half of 34 is 17. Or you can do 3 parentheses 6 minus 1. You're just plugging in that 6 in that x. 3 times 6 is 18. Minus 1 is 17. However you want to get it. Okay. Alright. Number 7. Plot these points. 2, negative 1. 5, 8. 8, negative 8, 0. Alright. So, you can tell right here we have an angle, we have a obtuse angle. It's bigger than 90. Okay, so it should be obtuse. It's not acute. It's not right. So it's not 2 or 3. The question is it isosceles or is it scalene? Okay. So you could use distance formula to find these missing lengths here. So let's do that real quick. And let me make my pen more manageable. So please remember, for distance formula, x2 minus x1 squared plus y2 minus y1 squared. I know y'all don't have a ton of room here. So 5 minus 2 squared plus 8 minus negative 1 squared. Okay, that's AB, BC, and AC. So the second one for BC is going to be negative 8 minus 5 squared plus 0 minus 8 squared. And then for AC, it's going to be negative 8 minus 2 squared plus 0 minus negative 1 squared. Okay, I'm going to take all three of those to the calculator real quick. Five minus 2 parentheses squared plus negative 8 minus 5 parentheses squared. Nope. Plus 8 minus negative 1 parentheses squared. There we go. Okay, 9.48. Square root negative 8 minus 5 parentheses squared plus 0 minus 8 parentheses squared. Alright, and then last one, negative 8 minus 2 parentheses squared plus 0 minus negative 1 parentheses squared. Alright, so we got three different side lengths, so hopefully you can already tell what the answer is going to be. It's going to be scalene. Let's write these numbers down though, just so we can have them on here. 9.49, 15.26, 10.05. That is not isosceles. This is scalene. Okay? So all three of those angles means it's going to be scalene, and then obtuse is going to be that angle right there. Okay? Alright, number 8. Draw the midpoints of each segment MN and NP. Alright, so MN, put that midpoint there. You kind of just eye it. NP, just kind of eye it. Connect them to form a mid-segment. Here's my mid-segment. If the segment MP is 8 centimeters long, what is the length of the mid-segment? So remember, X, the mid-segment, equals half of the parallel side, 8. Or 8 divided by 2, which is 4. That's it. Cool. Next one. Use the figure to answer line A and B. What's the equation for line B? Okay, we cannot forget y equals mx plus b. Okay, this is rise over run, and then this is the y-intercept. So let's do that. Let's find the rise over run and then the y-intercept. So for B, starting at here, it goes down 1, right 1. Down 1, right 1. So for 9, so it's going to be y equals negative 1 over 1. That's my slope. X. And then what's my y-intercept? So here's 0, 0 right here. Down 1, 2, 3, 4, 5, 6. That's minus 6. Okay, so negative 1 over 1 just means negative x and then minus 6. Same thing. And then for the so now it says what's the slope of line B? Well, we already found it, negative 1 over 1. Okay, so now what's the equation of a line parallel to line A? Okay, well, for parallel, that means same slope, right? So I need to find the slope of line A. So here's my line A. It seems to be going up 1, 2 over 1, 2, 3. 2 over 3. So this m over here is 2 over 3. For a parallel line, I'm going to use the same slope, so y equals 2 over 3x. But I have to use a different y-intercept, so I'm not going to use 4. I can use plus 2. Any number besides 4. All right. MNP is scalene. Draw the median PS. Okay, so a median goes from a vertex to a midpoint. Call that S. So these will be the same. Complete the following. MS is congruent to SN. Angle MSP plus angle NSP. Together these make a straight line. That's called a linear pair. Okay? It equals 180 degrees. Now I know I didn't say measure, but it should say measure, little m. Little m. MSP and NSP are, like I just said, a linear pair. Anytime they make a straight line of 180, they are a linear pair. Okay. 13, using the following figure, find the measure of the unknown angles WYZ out here. Well, if that's 29. 180 minus 29 is 151 degrees. XWY. Okay, so if this is 90 and this is 29, we're going to add them up. 90 plus 29 gives me 119. And then 180 minus 119 is 61. So XWY, 61 degrees. And then for VWY over here, all I got to do is subtract that 61 from 180 again. It's going to be very familiar because it's going to be what I had before in 119. Using the exterior angle theorem, we could have figured that out too. Okay. So 119 right. (14) which of the following equations would produce a graph that's perpendicular to the one shown? So perpendicular, we need an opposite reciprocal slope. So let's find the slope. It actually goes from here to here, so that's up 3 over 5. So if this slope is 3 over 5, my perpendicular slope is going to be opposite reciprocal. Positive becomes negative. 3 over 5 flips to become 5 over 3. So which one of these answers has negative 5 over 3 as a slope? Nope, nope, and nope. So that's the slope that I need. Opposite reciprocal slopes. Alright. Triangle side lengths in order from least to greatest. First off, let's find this missing angle. 28 plus 85, 113. 180 minus 113 is 67. Yep. So I put 67 right here. The least is across from the smallest angle. So across from 28 is NP. That's a side length. Across from 67 is MN. And across from 85 is MP in order. Okay? We need to classify these parallel, perpendicular, or neither. 3 over 4, 4 over 3. Those are not perpendicular. They're both positive. Okay? This is neither. They're going to intersect and not make a right angle. Okay, in Roman numeral 2, negative 1 over 5, negative 1 over 5, that is parallel. Same slope. Okay, negative 1 over 3, positive 3 over 1, that is perpendicular. That's opposite reciprocal. Change the sign, flip the frac. Okay, 3 over 2, negative 2 over 3, hey, that's perpendicular. They flip the fraction, and they change the sign. Alright. BC is a mid-segment. If it's a mid-segment, that's a midpoint. That's a midpoint. So each of these will have to be half a 12, 6 and 6. So what's the length of BU? 6. Easy. Okay. Up here, what are the coordinates of midpoints DE, EF, and DF? Again, easiest way for EF. Does everyone see EF has a horizontal change of 4? So what I'm going to do, so let me show you with the mouse. EF, F is right here, and then E horizontally is above my cursor right here. So between these 4, I'm going to go over 2, go straight up, and put a point. Okay? Okay, and the lines are a little off, so, oh well. For DE, same idea, so this goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So half of 10 is 1, 2, 3, 4, 5. And then you go straight up, and you put a point on it. Okay. And then half of DF, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So half of 14 is 7. 1, 2, 3, 4, 5, 6, 7. Boom. Okay, that was a lot. So what are the coordinates of the midpoints? So the midpoint of DE is negative 2, 0. Okay, the midpoint of EF is 5, 0. And the midpoint of DF is 0, negative 5. Another way to do this is using the midpoint formula. Okay, so remember the midpoint formula is x1 plus x2 divided by 2. Okay, it's another way to do it. ABC is similar, so similar means same angles. Okay, so that means A is going to match X. Okay. So what I'm going to do is I'm going to make my little triangles here. So A, B, C is supposed to match X, Y, Z. Okay. So if B is 90, now this is not drawn to scale, of course. That means Y is going to be 90. If Z is 40, C is going to be 40. Let's find that missing angle. Okay, 90 plus 40 is 130. 180 minus 130 is 50. So I got 50 and 50. So the measure of angle A, 50. The measure of angle C, 40. The measure of angle X, 50. The measure of angle Y, 90. Measure of angle Z, 40. Okay. Alright, so it says AC is 20, AB is 12, XZ is 5, YZ is 4. So we're looking for BC. Okay. So I'll call BC my X and XY my Y. If I were to make my connections, 20 goes to 5, X goes to 4, 12 goes to Y. So to find BC, I'm going to do X over 4 equals, and then 20 over 5. I can cross multiply. I'll get 5x equals 80 divided by 5. X equals 16. And then for y, I'll be 12 over y equals 20 over 5. Cross multiply. 60 equals 20y divided by 20. Y equals 3. So xy equals 3. Not a lot of room. Oh well. 20. State whether or not each set of links would form a triangle. So remember the triangle inequality theorem. The two smaller sides must add up greater than the third side for it to be yes. So 3 plus 5 is 8. 8 is not greater than 9. No. 7 plus 4 is 11. 11 equals 11 cannot be equal. That's also no. 32 is greater than 17. Yes. 18 is greater than 16. Yes. 7.8 is greater than 7.7. Yes. Alright, so what we're going to need to do is add up these two. So 5.5 is 5.5 plus 7 3/4 is 7.75. And is that greater than or equal to 13 1/4? Okay, that is 13.25. So no, because they're equal. Alright. Alright. Next one, classify DOG by its side lengths and angle measures. So every side is different. Okay, so we have scalene. We have one angle greater than 90, obtuse. 22. Okay, if we have three angles, we know they add up to 180, so let's just add them up. Okay, so we got 90 plus this, right? So 4x plus 30 plus 9x minus 5 plus 90 equals 180. So 4x plus 9x is 13x. 30 minus 5 plus 90 is 115 equals 180. Get rid of the loner. 65 divided by 13. X equals 5. And then we got to plug it back in. So 4 times 5 plus 30. Okay, it's 20 plus 30. That's 50 degrees. Nine times 5 minus 5. 45 minus 5 is 40. Okay. Answer the following questions by matching the description. Okay. Right scalene. Right angle. Every side is different. That's scalene, right? Alright. Equilateral. All sides should be the same. That would be letter C. Okay. Acute isosceles. Now, E is isosceles, but it's not acute. And then F is isosceles, but it's right. Letter B has 3 acute angles, and it's isosceles, so that's the answer. Obtuse isosceles. So again, F is right and isosceles, but E has the obtuse angle, and it's isosceles. Letter E. Okay, 27. Value of x. Again, the exterior angle equals the sum of the remote interior angles. So that's what we're going to do. We're going to add these up. 5x plus 5 plus 3x plus 5. Add those up, and that's supposed to equal this exterior angle, 130 degrees. 5x plus 3x is 8x. 5 plus 5 is 10. Get rid of the loner. And then divide by 8, the coefficient. So x is 15. That's all we're looking for. Alright, use the figure below to answer question 28. What's the value of x? If I have congruent sides, then I can set these values equal to each other. So I will. 5x plus 3 equals 6x plus 1. I'm not combining like terms because x is on both sides of the equation. I'm going to get rid of the smaller one. Minus 5x minus 5x. 3 equals 1x plus 1. And I just get rid of my loner on the right side. 2 equals x. Okay. Determine the measurements for the following angles. Angle A. Okay. So remember the kind of shortcut we learned? That all these obtuse angles that go in a zigzag, they're all congruent. Right? So 120, 120, 120, 120. It's alternating every other. Whenever we have two parallel lines cut by a transversal. Then the other four that are alternating kind of in a zigzag fashion is the supplement of 120. So we'll subtract 120 from 180 to get 60 degrees. And we'll just label that for the other four angles. So the measure of angle A, 60 degrees. Measure of angle B, 120 degrees. Angle D is 60 degrees. It's not that hard to do once you've labeled it. The answers are already labeled for you. What type of lines are M and N? Again, we just labeled that right here. And we just talked about. This is called parallel lines cut by a transversal. Okay? So when they do not intersect, we call that parallel. So let's name these angles. A and B make a straight line, and they're adjacent, so we call that a linear pair. H and A are outside of the parallels, so they're exterior, and they're on alternate sides of the transversal. That's alternate exterior. C, for A and E, they're on the same side of the transversal, but one's interior, one's exterior. This is the weird one. This is called corresponding. They're in the same position, just shifted down the transversal. Okay, B and C at an intersection are across or opposite of each other. These are called vertical angles. D and E are between the parallels, so they're interior, alternate sides of the transversal, that's alternate interior. B and H are outside the parallels, so they're exterior, they're on the same side of the transversal, so that's same side, exterior. And the only one we didn't label would be like C and E. Those are same side interior. If you wanted to throw an extra one in there. Okay. Solve for X. So remember, our same sides are supplementary. Okay. One's obtuse, one's acute. They're definitely not going to be congruent, so do not set them equal if they're not congruent. Okay? In this situation, when they're supplementary, we have to add them up, and it equals 180 degrees. So once we set it up, we combine like terms. 130 plus 2x equals 180. Get rid of our loner. And divide. So I got x equals 25. Now over here, these are alternate interior. These are congruent. So in this case, we are going to set these equal to each other. Minus 2x, minus 2x. X plus 2 equals 17. Minus 2 to get rid of the loner. X equals 15. So again, same side exterior are supplementary. Alternate interior are congruent. Okay. All right. So Euclidean and spherical geometry, the sum of the interior angles of a triangle do not add up to 180. So remember, Euclidean, we can call it, air quotes, normal. That's what we've learned this year in regular flat geometry. Okay? And spherical is the one that breaks the rules. So if this one is not going to add up to 180, that's spherical. Okay? It can be greater than 180. Triangle can have more than one 90-degree angle. In flat Euclidean geometry, if you have more than one 90-degree angle, it's not going to make a triangle. So this is spherical. I showed you how a triangle on a ball can have three 90-degree angles. So again, it's spherical. The shortest distance between 2 points is a straight line. That is Euclidean. That's regular flat geometry. Spelling this wrong. There are no straight lines. That would have to be spherical. In spherical, we call them great circles, not straight lines. The sum of the interior angles of a triangle add up to 180. That's regular, flat, Euclidean geometry. And again, flat space is Euclidean geometry. And we got some true-false. Spherical geometry, perpendicular lines intersect once. False. Okay, a great circle, like lines of longitude, intersect twice, like at the poles. If this was my sphere, in blue here, I'd have a line like this, and I could have another line like this, but they are definitely intersecting at each pole. Okay? Great circles are lines, and great circles intersect twice. In Euclidean geometry, parallel lines never intersect. That is true. Okay. Three angle measures of a triangle are given. Determine whether the triangle exists in Euclidean geometry. Spherical geometry, or neither. So again, Euclidean equals 180. Spherical will be greater than 180. And neither, it will be less than 180. So all we gotta do is add them up. So let's add up 42, 43, and 44 real quick, and then we'll know. 95 plus 84 plus 33. 58 plus 26 plus 96. 46 plus 17 plus 77. 212, 180, 140. So 212 is greater than 180, that's spherical. Equals 180, that's Euclidean flat geometry. And less than 180, 140 is neither. Okay. Do that. Okay, 45, find the coordinates of the centroid. How do I make a centroid? With three medians. How do I make a median? Connect vertex to midpoint. So, let's find the midpoint of SQ. Between 0 and negative 5 is 2.5. Go straight up, put a point. Between 0 and negative 4 is negative 2. That's easy. Between negative 4 and negative 5 is halfway. Go straight up. And let's connect these midpoints to each vertex. Oops. And what do you know? We got a intersection point, a point of concurrency, as we say. And that's going to be at -3, +2. That's my centroid. That's also going to be where it will balance. Remember that problem? Alright. Moving on. What are the coordinates of the midpoint of DE? Okay. So halfway between 0 and 3 is -1.5, comma 0. Okay, and you could add up these points using 0, 0, and -3, 0. You could have done 0 plus -3 over 0, and then 0, sorry, over 2, my bad, hold on. 0 plus -3 over 2, and you could have done 0 plus 0 over 2, -1.5. Okay, either way you want to do it, graphically or using midpoint formula. And then we need the length of FD, so we need these points. F is -3, 3. And letter D is 0, 0. So, square root x2 minus x1, 0 minus -3 parentheses squared plus 0 minus 3 squared. Take it to the calc. Square root, parentheses, 0 minus -3 parentheses squared plus 0 minus 3 parentheses squared. Enter 4.24. We'll go with rounding to the hundredths, or I guess the tenths. 4.2 for our multiple choice answer. Okay, similar and congruent, given that triangle GOL is similar to TAC. So let's mark this up. The first letter is G, first letter is T. Order matters, and we know that for similar triangles, the angles are congruent. So let's put an arc at G and an arc at T. So that means angle G is definitely going to be 98 degrees. Okay, angle O and angle A should be congruent in their measurement. O is 26, so A is also going to be 26. So, I know I can find my missing angle by adding up the two I know. I get 124, and I subtract that from 180, and I'm going to get 56 degrees for C and for L. Okay, so angle C is 56 degrees. Okay, RST is congruent to XYZ. RS is congruent to which of the following? So again, first two letters is RS. First two letters is XY. Order matters. You could draw a picture if you need the visual, but again, if you follow the order of the congruent statement, you will know exactly what is congruent without a picture. Just saying. But just to draw it, RST, and in the same order, XYZ, RS, congruent to XY. Alright. Triangle sun is congruent to triangle tan. What can we conclude? SN, AN. Now, SN are the first and last. AN are the last two. Nope. S is congruent to N. We don't know anything about that. Those are on the same triangle. Nope. T is congruent to U. Well, U is the second vertex. T is the first vertex. Those don't matter. I mean, those don't match, so they don't. We don't know that. And then SU, first two. TA, first two. Order matters. Angle. So letter D is going to be correct. Those two side links are congruent. Okay, so order matters again. Okay, ABC and DCE are congruent by what theorem? Please remember, if you see two lines intersecting at an X looking thing, you're going to have vertical angles that you should label. If you don't label them, it's going to be hard to find the theorem. And we just learned this stuff, and we remember we follow the edge. So we have angle, then we have a side with a tick mark, and then another angle. Angle, side, angle. ASA. If AB is congruent to AD, let's label that. AB tick, AD tick. By the way, they are touching. Two touching triangles. I should definitely label a tick mark where they touch, so I'm reminded that those are congruent segments on each side. Angle DCA is congruent to BCA. So DCA, BCA. Okay. Now, if we look at this, and we see we have angle, side, side. But we are not going to write down that acronym in my class. We also know it's not a theorem that works all the time, so we cannot use it. So angle side to side is not even an option. We know it would have to be D. Now, technically, these two angles that are congruent, that make a straight line, should be right angles, if you ask me, which would make it HL. Because those are 90-degree angles, but we need to fix this one. So, all right, 53. Given 8x minus 1 equals 3, parentheses 2x plus 3. Let's prove x equals 5. So all you got to do is tell me the property that we do for each step. So number one is always what? You always start with what is letter D, given. Always start. Let's put that there, always. Always given first. Alright, so from step 1 to step 2, I see that those parentheses went away because I distributed that 3. 3 times 2 is 6, 3 times 3 is 9. Distributive property, that would be letter B. From step 2 to step 3, my 2 x's on each side are now 1 x on the left-hand side because I got rid of my smaller x. And what did I do on both sides? The operation is subtraction, so that would be letter A, subtraction property of equality. Number 3, I get rid of my loner, adding 1 to each side, so that's going to be addition property of equality. My last step to get rid of that 2 coefficient is to divide by 2. That would be division property of equality. Alright. Name the angle pair. So again, at an intersection, across from each other, those are called vertical angles. And if they're vertical, I know they're congruent, so I'm going to set them equal. 5x plus 6 equals 8x minus 3. Get rid of the smaller x. Get rid of the loner. And then divide by the coefficient. I end up getting letter B. Now these are not vertical, they're next to each other, they're adjacent, and they make a straight line of 180. You could call them supplementary, but we call them a linear pair. Linear pairs are supplementary. Okay, these are not congruent angles. Okay, so we are going to add them up equal to a straight line, 180 degrees. Okay, so 3x plus 25 plus 2x equals 180. Combine like terms. Get rid of the loner. Divide by the coefficient. We get 31, or the value of x. And then for these, so supplementary angles are angles that add up to 180 degrees. They don't have to be adjacent. Complementary angles are angles that add up to 90 degrees, and again, they don't have to be adjacent. A point is a location with no size, no width. A line, it extends both directions forever with no thickness. A line segment is part of a line between two endpoints. A ray has one endpoint and extends in one direction forever. A midpoint is a point that divides a segment in two equal parts into halves. And an angle bisector is a ray that cuts an angle in half into two equal parts. Perpendicular lines are two lines that intersect at 90-degree angles. Parallel lines are two lines that never intersect. And a acute triangle is a triangle with three acute angles. Alright, and the last page, an obtuse triangle is a triangle with one obtuse angle. A right triangle is a triangle with one right angle. A scalene triangle is a triangle with no congruent sides. All the sides are different lengths. An equilateral triangle is a triangle with all three congruent sides. An isosceles triangle is a triangle with two congruent sides. An exterior angle is an angle outside of a triangle made by extending a side. The triangle sum theorem is the angles inside of a triangle add up to 180 degrees. The triangle inequality theorem says the sum of two angles in a triangle is always greater than the third angle. An exterior angle theorem says an exterior angle is equal to the sum of the and that is wrong, two remote interior angles. An exterior angle is equal to the sum of the two remote interior angles. Converse is when you switch the hypothesis and conclusion of a statement. The inverse is when you negate or make opposite the hypothesis and conclusion. Notice an inverse does not switch anything. It only negates. Biconditional is a statement that is true both ways. Okay, so the converse and the original conditional are both true, and you use the phrase if and only if between your hypothesis and conclusion. And then contrapositive is a converse and it. So a contrapositive is when you switch and negate the hypothesis and the conclusion.